Hi everybody, it's negative exponent day. So you're going to need two things. You're going to need your Laws of Exponents paper, which should be about halfway filled out. And then the new paper is contains exercises for negative exponents and then for rational exponents. But for this video, we're just going to be talking about negative exponents, and we're going to start with the overview of all the laws and go down to the row that says negative exponents. And let's zoom in. Okay. So, negative exponents are not actually negative numbers. I mean, the exponent is negative, but that does not mean that the number, like the answer to it, is not going to be negative necessarily. So let's revisit the pattern that we started talking about like what is an exponent. So it's repeated multiplication, right? So we were 5 cubed, 5 squared, 5 to the first, 5 to the 0, and we're decreasing the powers, and we had talked about that that's just dividing by 5 over and over and over again. So if we kept that going, so let's fill in a little bit down here. So let's say, 5 to the first was 5. 5 to the 0 was 1, because we were dividing by 5. Well, what if we go down into the negative numbers for our exponent? Then we have 5 to the negative 1. According to the pattern, we would need to take 1 and divide it by 5. Well, 1 divided by 5 is 1 over 5, or 1/5. And then if we do it again, 5 to the negative 2 would be 1/5 divided by 5, which is 1/25. So it seems that the negative exponent sends the power to the bottom of the fraction. So here's the way I like to think of it. This is kind of weird, but you guys already know that I'm weird, so I like to think of my negative exponent as it's like raising a tiny little hand and being like, excuse me, trying to get your attention. Speech bubble. Excuse me. Because that's how exponents talk, because they're really small, so they have a squeaky voice. So it's trying to tell you, excuse me, I would like to be moved to the other side of the fraction. I'm not happy where I am, and I want to be moved. So we have this explanation here too, that powers with a negative exponent can be written as their reciprocal, which means reciprocal, refliprocal, turn it over or move it to the opposite side of the fraction. But then once you flipped it, once you do the reciprocal, then it will have a positive exponent. So let's try some examples. Turn to the first row of examples here for negative exponents. So x to the negative 3. We do not consider negative exponents to be simplified. So even though this is pretty simple, negative exponents, we can put it here, are not considered simplified. So when we're working, we want to make sure that we just don't have anything that can be combined at the end, but also we don't want to have any negative exponents, because the negative exponents are raising their hands and saying they're unhappy. So we want to make them happy. We don't want crying exponents. Okay. X to the negative 3. That's a fraction bar. And this means that to simplify this, I'm going to have to move that to the bottom and then make my exponent positive. And then there's nothing left in the top, so I'm going to hold the place with a 1. Okay, second example, we have 2x to the negative 3, and you have to be careful because what does the exponent negative 3 apply to? Does it apply to the 2 and the x, or just the x? If you were thinking just the x, you're thinking right. So if I'm going to have a fraction now, my 2 will stay in the numerator because it's not being affected by the power of negative 3. But then to satisfy my crying negative exponent, I'm going to simplify it by putting x to the third in the denominator. Okay, this time the negative 3 is applied to the parentheses, which means it's applied to the 2 and the x. So the 2 and the x will be sent to the denominator, and then they still are being cubed, but now it's a positive 3, and there's nothing remaining in the top, so you put a 1 to hold the place. When you have a fraction raised to a power, you need to apply the power to the top and the bottom of the fraction. So one way to think of this is x to the negative 3 over y to the negative 3. But now they're both negative, which means they both want to move to the opposite side. So we're going to end up with y to the third, because the y to the negative third says that this needs to be moved to the top to fix the negative, and this needs to be moved to the bottom. And then it will become x to the positive 3. That's all that you can do, because you can't combine powers of y and powers of x. So you may notice that when we had a fraction raised to a negative power, we basically ended up with the flipped upside down version of the fraction, which is called the reciprocal. So let's make a little note to ourselves here. A fraction to a negative power exponent means reciprocal. Reciprocal. Okay. Here's another one. It's another fraction raised to a negative power. So instead of doing it the way I did it before, where I applied the negative 2 to the top and the negative 2 to the bottom, I'm going to flip my fraction over, so 3 over 2x, and then just write it to the power of 2 instead of the power of negative 2, because that's a little shorter way of doing it than the way I just did it. But I still need to square now the top and the bottom. So 3 squared is 9, and 2x squared, well, 2 times 2 is 4, and x times x is x squared. So that's 9 over 4x squared. All right, let's tackle the second row, and then we're done. 3x to the negative 4y squared z to the negative third. Well, I have some negative powers here that need to be simplified, but so what stays in the top is the 3 and the y squared. I can't combine any of this stuff because I have x, y, and z as my variables, but the x to the negative fourth wants to move down as an x to the positive fourth, and the z to the negative third wants to move down as z to the third. So this is just considered simplified because we don't have any negative exponents. Same thing with this one. We can't combine these powers because the bases are x and y, so y squared will remain in the numerator, but x to the negative 3 will move to the denominator and become x to the positive 3. Okay. This might be the first time we've seen this. So this is a negative exponent that is in the denominator. So we don't move it to the denominator because it's already there. So that negative exponent wants to be moved to the numerator. So now in the numerator, we have x to the 5th times x to the positive 2. There's nothing left in the denominator, so you put a 1, because everything's a fraction. Okay, so that's x to the 7th. Add. Okay. So for this one way to do it is to fix the y to the negative 2. So if you rewrite that, you would have 1 over y to the positive 2 to the 5th. Then you can do the top to the 5th. So 1 to the 5th is 1. Doesn't matter how many powers of 1 you have, it's going to be 1. And y squared to the 5th, we have a power raised to another power, so that's going to be y to the 10th. But I want to show you another way to do this. So sometimes, instead of just as your first step cleaning up your negative exponents, sometimes you want to just go ahead and do the multiplication. So for this, let's just say just multiply the exponents, because these are powers raised to powers, and then simplify later. Meaning clean up your, clean up your negative exponents later. Some of this you'll just learn by trial and error. So if we do this multiplication, this would be y, and then it's negative 2 times 5. So we have y to the negative 10th. And then we can just fix that by making it 1 over y to the 10th, which is the same as that. Because for this one, that's going to save us a lot of work, because we'd have to fix this negative exponent and then fix that whole big fraction. So if we just do our power to power rule, it'll be x, and then negative 3 times negative 5 is positive 15. And we're done. So I hope you enjoyed negative exponents. I think they're very exciting.